This Week in Radio Tech, episode 307, is brought to you by Axia AOIP audio consoles and routing systems. For a single studio or a major multi-studio production facility, Axia AOIP scales with you. By Zipstream, sponsor of Streaming University from the Telos Alliance, 14 video lessons in high-quality audio streaming. And by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. Hey, having designed and installed remote control systems and automated testing on both sides of the U.S., Doug Irwin is uniquely qualified to talk about the benefits and some pitfalls. As the technical editor at Radio Magazine, he's also seeing changes in broadcast engineers' skills and work emphases. Doug joins Chris Tobin and Kirk Harnack on this week's TWiRT. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Delighted that you're here with us. This is the show where we talk about radio technology, everything from, I do have a microphone prop every time I do the show. Isn't that great? So it's very convenient. Everything from the microphone in front of the DJ to the light bulb at the top of the tower and everything in between. And, we in this world of radio nowadays, we have digital this and audio over IP and digital transmission and IP-STLs and, oh my goodness, and streaming. We got streaming too. And so there's so much to talk about and work through and just make sure we're kind of all on the same page, or at least understand the page that we're on. So welcome into the show. I'm glad you're here. We've got another terrific show put together, as usual. Oh, by the way, I'll tell you where I am. I'm not in my usual office. The folks at Entercom in Atlanta have been graciously allowed me to use one of their studios. In fact, this is the morning show studio. It's just for the morning show. How about that? They're like, now it's afternoon, so the afternoon guy's in a different studio down the hall. But this is the morning show studio, and since there's nobody in here right now, they let me use the studio. Beautiful microphone, the Shure SM7, and that's just great. So I appreciate Scott Trask and Al Reynolds for letting me come in here and do the show from here. It's just been great. I'm on my way driving. I'm going to be on vacation, actually, so I had to have a place known bandwidth to do the show. All right, that's where I am, and let's check in with our usual co-host. He's usually here. And he's usually Chris Tobin. Hey, Chris, welcome in.
Hello, Kirk. Yes, I am here. I'm in the flesh, as they say. And this is the guess the undercarriage behind me.
The what?
For those of you watching. Yeah, guess the undercarriage behind me.
The undercarriage of what?
Can you see it?
I'm not.
Can you see this?
Oh, I am. Yeah, I see it now. I can't tell what it is, though.
Oh, yes.
What is it?
Well, all right, fine. I'll show you what it is. There we go.
Oh,
now do you recognize it?
Well, yeah, it's been 20 plus years since I've seen one of those underneath, because I fixed some of those about 20 years ago. And that's the last time I've seen one.
It's an Otari
Wow.
MTR 10-2, 2 for 2 tracks. There were no razor blades inside, plenty of oxide there.
Yeah. The razor blades and pens usually get dropped in the pan somehow, right?
That's right. That's absolutely right.
Yeah. And, be glad you didn't find an old tuna fish sandwich in there, because that's been known to happen, too.
No, this one's in pretty good shape, but I have worked on a few that have had some interesting things inside, yes.
Oh, there's those tickets to the concert I was looking for,
Exactly.
Jeez. So, Chris, you're coming to us from the New York City area?
New York City area. I'm coming from the premier jazz station, WBGO, in New Jersey. Yes.
Good deal. All right.
Yes.
Well, you know our guest, because I guess he's a former New Yorker, now back on the West Coast. I'm delighted that he could make time for us. It's Doug Irwin. Hey, Doug, welcome in.
Chris and Kirk, thank you very much for having me. Yeah, it's great. Yeah, it's been a while, but here I am, back out in California.
Doug, we're going to get to our first commercial pretty soon, but why don't you go ahead and fill us in? Last time you were here, I believe you were engineering at iHeart in the New York area. And you've made some changes since then. What's been going on since then?
Right. I was at iHeart there in New York and working for Josh Haddon, of course, and living in New Jersey. And last time I was on your show, I was in my apartment in New Jersey. And this time I'm in the Dennis Slotman's office here in L.A. So walls are all white and it's bright in here. And it's we're in the middle of a renovation right now. So if you hear any noise or things going on in the background, that's pretty much the reason. But yeah, so I'm out here with iHeart Media in L.A., pretty much doing the same thing I did in New York. Working on transmitter sites, mainly doing external stuff. We've got our whole staff here and local people that do the building here, and I work mainly in the field. So, but here I am today.
And then by working in the field, last time you were on, it seems like you were talking to us about remote control systems, that was one of your passions, to make those really work well and to deliver meaningful information back to the central control point. Isn't that what we talked about?
Probably so. I was spending a lot of time working on Relio from Automat then. You might pronounce it Relio, but I always call it Relio. We spent a lot of time automating it and making automated functions here in LA. We're a Burke house, and the same exact thing happens. Dennis Sloatman is our in-house expert on Burke, and I am picking up more of it as time goes on. Because back in New York, my experience with Burke was the ARC 16, basically. We moved to the Relio, but here we're using all the very latest stuff for Burke, so I'm playing catch-up as far as that goes.
And then the other role has been technical editor at Radio Magazine. And for those who, I'm sure almost everybody's got to know about Radio Magazine. Of course, there's Radio World. That's one of the industry publications. And then there's Radio Magazine, which, didn't radio start out? Didn't it? What's the word I'm looking for? Spin off from broadcast engineering many years ago, right?
Right. It spun off from that. It used to be called BE Radio, and at one point it was just called Radio. Thereafter, I think it's probably like 15 or 16 years ago. I'm not exactly sure. I don't know the history on that, but yeah, it's been quite a while. Of course, Chris Scherer was the editor for many years, and before him it was Skip Pizzey, and for a while Shane Tobin, as you know. And I took over for Shane about 15 months ago or so, as I recall now. Yeah, it's been like 15 issues, I think. Seems like it's going along very fast. So yeah, remote control is a big part of what I do and what my interest is. And here it's a little bit different because, as I mentioned, we're changing. I've had to change gears essentially and go to a different manufacturer, but. Automation is the big key in getting things to work in a fashion where we don't have to intervene. We don't have to be woken up in the middle of the night, hopefully, for the system to take over and fix itself, and then send us an email later. So,
yeah. So we're gonna talk about some of your passions in broadcast engineering here in just a few minutes. For my first ad, though, I'm going to use some pictures right out of Radio Magazine. One of the cool things about Radio Magazine is it's a slick paper magazine, and so. When you print pictures in that magazine, they look really beautiful. And so you guys at Radio Magazine actually strive to get really pretty pictures to go along with the articles to emphasize the text in the article. So our first sponsor is Axia, and the range of Axia consoles and X nodes and just all the things that plug into Axia, the audio over IP networked audio system from the folks at the Telos Alliance. Let's take a look at this article. This is a beautiful article about a gorgeous facility. It's the Cumulus Nash, I think they call it their campus, Nash campus, where they do a number of country shows. In fact, those studios that you see right there, and as I go through the ad here, Suncast is going to scroll through that a little bit. That studio right there, that's the control room for America's Morning Show, which is where Blair Garner does his show with country music artists every morning, every Monday through Friday morning on 100 stations or so, and they just do a really bang-up job. Beautiful. I mean, just great work. The studio is through that window you see there, and it's a I guess you'd call it a full-color studio. There are pan-tilt zoom cameras, HD cameras in there, and I don't know what they're doing with the content that they make on that. That's not my business. But my business was helping to arrange for and put in that console that we're seeing there in the picture. If we could go to that, it's a split. They want a split console there, and their producer stands right there in the middle of the split, handling microphones, handling live audio from CNN headline news. They go to that pretty often. They have an ISDN box there, the Telos Zephyr, the Zephyr Extreme there, and so this was the first studio built in that facility. I don't know if it's possible to scroll on up through the article there to see other pictures. But after they built, right there's part of the rack room. You see part of their automation systems and some other Telos gear on the right-hand side. That's the Telos VX system. Scroll a little bit farther down, and we're going to see the second studio that got built there. And here's what was really cool. I know I've talked about this before, but they built the second studio for Nash Nights. Now, that's Sean Parr, who's sitting there at the microphone with his hand up in the air. And then that's Elena, who is his sidekick. She is over on the left-hand side. She's the pretty one. And so they built this second studio, and guess what? They connected it to the rest of the whole facility literally with one Cat6 cable. One Cat6 cable made that happen. Scroll a bit more there and we see some of the, they built this furniture, and instead of regular furniture legs, it's a guitar neck for the legs on that console in the Nash Knights studio. That was pretty cool. Of course, Axia, we don't care what you do for furniture. Scroll down a bit more, and that's where they produce American Country Countdown. Now, they don't use an Axia console in there. They use a kind of a standard recording studio console, but they do have an Axia node in there that ties them into the rest of the building. They have a Telos VX phone in there, and they have, of course, a Telos Zephyr Extreme in there to do artist interviews from other places. But that's where Kix Brooks does American Country Countdown. And then there's the basketball court, which has absolutely nothing to do with IP. So bring it back to my camera here, Suncast. The point of this is that whether you're building a small facility like, say, my radio stations in Cleveland, Mississippi, or whether you're building a large facility that depends on absolutely reliable operation for a nationwide morning show with high visibility hosts and guests, high visibility evening show, Nash Nights, again on 100 stations or so throughout the country. And they do all kinds of artist interviews. This week is CMA week in Nashville. And so they're interviewing artist after artist after artist in a third studio that's also using an Axia console. All the stuff networks together. You get the infrastructure put together with a core Ethernet switch and your nodes to get audio in and out. And adding more studios becomes really simple and almost easy. You plug the stuff in, you do some configuration on a browser, and next thing you know, you've got a studio that just does everything that you need it to. Hey, some of those interviews that they do, by the way, are pretty complex. They're doing satellite interviews, and that means they do a lot of split operation, left-right headphones, left-right speakers, so people can hear questions from the radio station they're connected to, and they can hear the answers coming from the artist who's in the studio. It's really amazing, and you can do all that with Axia. I should mention the Axia Element and the Fusion with the new 3.0 software. If you need some really super split monitoring and split functions going on, check out the new 3.0 software for the Element and the Fusion. So our show brought to you in part by Axia, putting studios together really easy. Oh, I should mention, get out of the way here, I'm in an Axia studio right here myself at the Intercom stations here in Atlanta. They are all Axia all throughout the facility, and this is a gorgeous Element console right here. They have a few other Element consoles, and I was here before they put Axia in, wiring out everywhere, and 95% of that wiring has been pulled out, and it's just some cat cables running around now. So much simpler and easier. Thanks, Axia, for sponsoring This Week in Radio Tech, and also thanks to Intercom here in Atlanta for, first of all, putting lots of Axia in and letting me come in here and do the show. All right, let's move right forward here. Doug Irwin, Chris Tobin are here with me on This Week in Radio Tech. Doug, so you do outside engineering. Does that mean you also take care of transmitter sites? Are you the RF guy as well?
Yes, I am, and I pretty much do everything from router output on through the air chain that starts with router outputs and all the racks and master control that had to do with that, all the various PPM encoders and audio processing and all the STLs and all their STL receivers and T1 shelves and audio over IP connections and so forth and transmitters and antennas, pretty much everything out of the building, which is quite a bit of stuff. I mean, we have 15 or 16 external sites here with iHeartMedia in LA, so it's pretty extensive. Our farthest site is 108 miles out by road, of course. So we've got a pretty widespread operation going on. And of course, we have some pretty famous stations. I mean, Kiss FM was one of our stations, and KFI, and My FM, which is K-Big, and it's a big operation. We've actually got I don't want to brag about it too much, but we actually have 3 of the top 10 billers in the country are actually in our group of 8 stations. We have
what?
Yeah, we have 10 total. Actually, we've got 2 out in the high desert as well. Yeah. So of course
but
we
you
count
have 3
those
of the top 10 billing stations. That's wow. That's I mean, good on your salespeople. That's fantastic.
Oh, they're very good. Yes, I'm sure they'd agree. So, yeah.
Wow,
it's a great place.
So
I mean,
Doug,
it's growing even more.
And hey, Chris, butt in anytime you want to if you want to ask a question here. But Doug, with all that going on, we have way more than one show's worth of stuff to talk about. We're going to have to focus on something. What, I know remote controls and automating that kind of thing is part of your passion. What else? You want to talk about, your various STL methods, your favorite transmitters, and, anything cool that you do at transmitter sites to help make them more reliable? You got any tricks to share with us? Just kind of where do you want to go with this conversation? Because we could go anywhere.
Well, I think what we're trying to do here ties in a lot with what I've been focusing on with Radio Magazine. That is how to try to make your job even easier. Because I don't know if you've noticed in radio, hopefully you have, is not only do we talk about technology, but we also talk about what it's like to try to cope with the job of being a radio engineer and try to make it easier. We try to focus a lot on backup systems, alternate ways to do things, and remote access to them, so you don't have to drive out to the transmitter site at 3 o'clock in the morning. As I'm sure Dennis would agree, he's the driving force behind this here. And another thing we're doing, which we're going to start getting into in Radio Magazine here, this coming in the July edition, is programmable logic controllers. We had one article about PLCs a while back. We're going to do a series now on PLCs, and the reason is because we're actually doing it now, but we're going to continue and do more using them to do automated functions. So not only do we have automation from remote controls like Burke, but also we're going to rely more on PLCs to do functions like changing audio sources for STLs and changing transmitters and so forth when it's called for. Another thing we do a lot of here is automated testing. So several of the stations have weekly tests. So backup transmitters are tested, and that includes firing them up, bring them into the dummy load, testing the audio, testing PPM, make sure it's there, and so forth. And then we get email reports afterwards. Which is always very gives you kind of a warm and fuzzy feeling that you know everything's working. But also, what happens not infrequently is a message from the remote control saying, "Hey, your test did not work." And so there's been several high-profile times where we discovered transmitters weren't working for some other reason, and we figured out from the automated testing. Didn't require a trip to the site to figure that out. So because we're doing a lot of things, we're running around. So with all that many sites, you want to have some way to be helped to know what's going on. So that's really what the emphasis is on remote control here.
I do remember, and Chris, you probably do too, the last time you were on, Doug, we talked a lot about this automated testing, which I found amazing, and still I'm a little bit lost in exactly what kind of steps that you're doing. So do you have go through a routine where your your remote control automated brings up a backup transmitter to the dummy load, checks the readings, determines if things are fine or not, then dumps it, maybe checks the backup STL system or systems. What all kinds of things can you do when you're automated like that? How thorough can you be in checking a site that you don't want to go to?
Well, of course, you can be very thorough. We have silent sensors, for example, in all the STLs. And actually, we typically use the audio processor output. So in other words, if you've got a backup audio processor, it's picked to listen to a backup STL. So having silent sensors on the outputs of them not only indicates that the processor itself is working, but that the STL it's picked is working. And if one of them dies for whatever reason, we get an email, of course, saying, "Hey, your link from point A to point B is down for whatever reason." Getting back to your initial question, and this is a routine that Dennis had worked out a while back, and it's one of my favorites. It's at KYSR, which is Alt 98.7 here. We have a Harris HD35 that gets tested once a week. It's a little bit more elaborate even than what I described earlier, because the dummy load fan isn't even running. So the system starts off by turning up the fan. The fan's on. It measures the current flowing through the fan to make sure the fan is actually going. Turns on the transmitter. Let's see what else. Measures looks at the audio. As I mentioned the PPM. Thank you. And after it shuts the transmitter off, of course, it sits there and measures the dummy load air temperature. And when the temperature is low enough, it shuts the dummy load off and it sends out an email about all these various things. So it's a great routine. We have another one in the high desert that there again, Dennis came up with this. This is his brainchild, where it turns up the backup transmitter, puts it on the air, takes the main, turns it off, runs it for a while, and then goes back to the main. And we get emails regarding the progress as it's going along, which is very cool. So automation's a big thing here. And as I said, if you're trying to take care of a widespread system, then you need some help, and it's best to deal with stuff that's already around. So, i.e., your remote control.
Hey, Chris Tobin, when Doug first started talking about this, he mentioned PLCs, and these are what, programmable logic controllers. Is that what PLC stands for?
Yes.
Yeah, I have never programmed one of these or thought I needed one. Tell me how a PLC could work in conjunction with a fancy remote control. Doesn't the remote control do everything you need? Maybe it doesn't. Maybe that's why you need a PLC. Talk to me about that subject.
PLC I am not an expert on this by any means. In fact, I'm pretty much a novice on this. I have done one particular PLC project, which is an antenna controller. It's up at K-Big's transmitter site. But we consider it to be much more reliable than remote control running on a PC, basically. PCs have a tendency to crash occasionally. We have ways to reboot them remotely, but still, if you find out it crashed in the middle of the night or middle of a routine, that's not good. The PLCs are meant to be doing industrial functions, and don't require another PC running. They're running the whole routine themselves. They're totally self-contained, and the reason that Dennis has got me into this, and the reason that they're good, is because not only they have the controller that you can program, but also they have relay logic and relay outputs and normal inputs that we're all accustomed to working on. So it's like GPIO of your normal remote control. So you write a routine, you in something called ladder logic. It's virtually impossible for me to talk much about it. As I said, we're having a series coming up about it. Ladder logic, it took me a while to get it and get the hang of it. It's not nearly as complicated as it first looks. I don't know what else to say about it. It's in a sense, it's old-fashioned because as I recall, and Dennis would correct me if I'm wrong, but I believe it's basically based on. I look at it as being logic used to control elevators and so forth. I mean, basically, you look at everything as being an input and an output, and you start from there. But it's a whole long topic.
Chris Tobin, how about at any of your stations? Have you been dealing with PLCs?
No, I have not had a need to. Nope, haven't come across those. Thank goodness.
Because I know some engineers, just as my good friend Joe Talbot, he's like. Let me use a different example. I had an uncle who he had a ball peen hammer that he loved, and any mechanical problem he came across, it was fixable with a ball peen hammer, because that's what he had, and he could unscrew a screw with a ball peen hammer, right? So
the piece of equipment behind me would be a ball peen hammer choice.
And like my colleague Joe Talbot, almost any weirdness, any problem with a voice over IP phone situation can be fixed by adding an asterisk, PBX, right? You want a function? Oh yeah, the asterisk will do that, because that's what Joe knows all about that. I know there are broadcast engineers out there, because I've talked to a few of them, who love PLCs. They understand this. Maybe they even came from the world of industrial automation, and so they implement them. But I never have. Chris, sounds like you don't have much experience with PLCs, but it sounds like Doug is getting ready to have some real experience with them.
Well, like I said, my experience is limited, but it took me a while to get the hang of using ladder logic. It's hard to describe to me personally what was a little bit odd about it. I mean, you've got an input, and then you've got an output, but you've got the output essentially shows up on the next rung of the ladder. It's hard to get into. It's not going to make any sense unless you were to look at it on a computer. But as I said, stay tuned if you're interested for Radio Magazine, because we're coming up with a series. We're going to do at least 3, but probably more than that. We're going to start off talking about what it is, what you can do with it, how to communicate with it, and then do very basic programs, and then start giving some ideas about more things you can do with it, like controlling STLs and transmitter, and doing stuff like measuring line pressure and transmission lines and so forth and so on, and making sure that you can tell an air conditioner is running and so forth. We take a very granular approach to all the stuff that's at the transmitter site. We want to know everything going on. Air conditioner has been called. Is it actually working? Generator's got the battery charger. Is the voltage too high? Is the block heater running? What's the current flowing through it? That kind of thing. We keep very close track of things, and PLC is just going to be one extra way that we can rely on something to do something for us and then call out later or communicate later saying, hey, I switched transmitters and everything's good. We're on the air, so don't worry about it. Of course, the most famous PLC application everybody knows about, I think, is Steve Tumwall's stuff, Tumwall Radio. All the transmitter controllers that he makes run on PLC, and my experience with them has been absolutely fantastic. So love that stuff.
That's true. It does. I've used that stuff. Now that I think of it, yes, I've used it for AM sites. Yeah, it works. It just runs.
Something
and
that
actually, I'm sorry.
Go ahead, Doug. Go ahead.
Well, I was going to say our AM transmitter site out in industry, it's KEIB. It's on 1150. The company made the phaser and the ATUs and so forth. Contronics, of course. Sorry, they made the whole controller of a PLC. I guess 20 years ago. There's nothing new about it. I mean, there's been a lot of changes, and they've gotten smaller, and a lot more manufacturers, evidently, from what I'm learning. But they've been around for years and years and years. How many years PLC's been around?
Since the 70s.
Just since the 70s. So yeah. 40 years plus.
And they've probably figured out how to make them very, surge proof, and they just work really reliably. Whether if you need some expertise in PLCs, I'll bet you could go to your local factory, almost no matter what they make. If they package rice or make underwear, they probably have PLCs on the production line. So that might be a good source of information.
Yeah, bottling plant, anything where there's a kind of rote manufacturing process that goes on and on and on and on and on. PLCs are designed for that kind of thing.
Well, they have the new update, Stuxnet version 3.0, I think.
Yeah, right. Yeah, don't plug any USB keys that you find on the ground into your network. That's for sure.
Well, there again, I mean, the PLC is an independent device. It's not connected to any network except for communication purposes. You don't have to do that even if you want to talk to it. There are some that have IP connectivity. Most of them are just serial connections. And of course, you might just decide to plug it in for a while and check the program or make changes in it, edit the program, and then unplug it and leave, and it'll sit there and run for however long you need it to. So,
of course, yeah, you're right. So, Doug, earlier you mentioned that the fan, for example, on the dry load that you're going to test the transmitter into automatically. You said that you switch it on. Well, that would be a relay. That's easy enough. But you also measured the current that the fan motor was drawing to assure that it's really running well, and the current's probably within range. If the motor was somehow jammed or stopped, it's probably going to overcurrent. My question is this: that it seems like one technology that broadcast engineers need to become more familiar with is sensing. So I recently purchased a 9-year-old car. It was a used BMW. And I'm amazed by all the sensors that must be in this car. It can tell me which license plate light is burned out, right? It can tell me left or right marker light is burned out. It's just amazing all the sensors that must be in there. It's, on the one hand, adds complexity. On the other hand, it tells you exactly, or pretty close to, what's wrong. And then if you've ever plugged into your OBD2 plug in your car, and then ran an app on a phone with Bluetooth connected to it, you can see an amazing number of parameters of your vehicle, including how much is the timing advanced at this speed and load on the vehicle. Just a plethora of stuff. Well, it seems to me that broadcast engineers are going to need to get familiar with sensing technology. You want to talk about that a little bit?
Well, yeah. I mean, there's not that much to a lot of these various sensing things. We measure the current flowing through the motor in the case of the KYSR dummy load. For the block heater for the generator, we measure the current flowing through that. There's not that much more to it really when it gets right down to it. I mean, you've either got a voltage that's there or a current that's flowing, one of the two. And of course, the nice thing about having a current flow measurement is the connection's made and something's happening. We were considered doing that with air conditioners as well, measuring the current flowing through a compressor, but in the meantime decided that we're just going to look at the signal calling the air conditioner from the thermostat, and then we're going to measure the exhaust temperature. That's going to be our way to tell if an air conditioner is really running. But we considered doing something like measuring the current from a compressor because, let's face it, it could be called and it could not come on for various reasons. How many times have you had a situation where you had a 3-phase compressor for whatever reason the contactor had a bad contact or whatever? I don't know how many times that seemed to happen in New York. It's an expensive fix.
Yeah.
So, hey, your contactor's got a bad connection. We had to change the whole thing out. $1,500. Anyway, so we can measure the current and kind of not even really touch the system and tell what's going on still. So one thing we've talked about experimenting with is airflow sensors. We haven't quite got to that point yet. We are trying to determine whether or not we've got a leaky transmission line. Well, why is the dehydrator running 25% of the time? Is the air flowing out of this one particular line? Well, yeah. Or is it flowing out somewhere else? So, there are things out there I have learned since I've been in this position. A lot of industrial sensors, a lot of companies that make stuff like that broadcast engineers are not aware of at all. And that's one thing we're trying to really cover a lot in radios, to get people to understand these things are out there. Think out of the box. Just don't look inside the universe of broadcast equipment. There's tons of other things out there and a lot of other ways to accomplish something.
Chris, I'll bet you're pretty familiar with the Granger catalog or other industrial catalogs, and you know where to go find something cool, like pressure sensors. Chris, I'd love to see, thinking about a transmitter site where you've got a number of transmission lines, you've probably got one of those, is it called a manifold? Where you take your nitrogen or your dry air source and you manifold it, put it in a manifold, and then it goes out, to various lines. Boy, what if you had on the outputs, you had a little solenoid that could close it off and measure the pressure over time and then open it back up so you could see which one of those lines is doing the leaking, and you could see that remotely. Wouldn't that be cool?
Yeah, I visited a place. They did have an inline monitoring on the pressure monitors, and they could watch and see what was going on, and they could tell which ones were leaking more than the others if there was a leak in some. It's pretty cool. There's a lot of stuff, and Doug is right. There's a lot of things outside of broadcast that we probably have not become that familiar with that we should have. I can say that with the air conditioning systems I've worked with at a couple of facilities, we definitely took advantage of the industrial sensor technologies and had some good times with checking the call of a thermostat and airflow or the temperature coming out of the exhaust. We didn't, and Doug's right, we didn't go as far as measuring the current on the compressors and stuff, which probably was a little too prohibitive. But if we get thermostat calling and air coming out and temperature of the air, at least we have that idea. We know what's going on. So it made sense, but it worked.
And of course, the idea is that if the air conditioner doesn't work for some reason, you want to know ahead of time. You don't want to be faced with getting a call at home on Saturday afternoon and saying, hey, the temperature's 120 degrees in the transmitter space, and go, ooh, I wish I'd known that air conditioner was working. So that's the kind of thing we're trying to get away from. We want to, and I did this in New York with Relial, and we're doing it out here with the Burke system. And that is, hey, we're measuring the temperature, and suddenly we measured a 10-degree climb over 10 hours or over 2 hours or whatever. Something is probably going wrong. We want to be alerted ahead of time. You don't want to find out when the situation's already a disaster. You want to try to find out as far ahead of time as you can, because the idea is to reduce the stress and not have to be faced with constant emergencies. So.
Yeah, no, you're right. Actually, in one facility, I helped put together speaking of Berg, their climate guard. I think that's the proper name. And we did exactly that. We'd set up, I think, 2 or 3 sensors in the room and set it up so that we could look at what was going on. We tested it by turning off the air conditioning, let the room temperature rise, and we were able to determine how long it would take and then set the alarm points accordingly. So at least we would know, like you say, early warning that, hey, something's taking place in the room and the AC may be at fault. Know now rather than until it's mission critical and the contacts are melting on the transmitter. If you're in a room that's sealed and doesn't have any way of bringing in air or exchanging the airflow. So yeah, there's a few things you got to look at these days.
So yeah, that's a wonderful example. Air conditioners. By the way, another thing to do with air conditioners, like certain ones have not only have a NIC card basically inside them, and you can make an IP connectivity. And what I did in New York, and what we're trying to get up to speed on here with Burke, is using SNMP more and more to tell what's going on with the air conditioners up at 4 Times Square. we used to monitor air conditioners and just monitor. We only did a couple minor things, basically internal temperature and so forth and so on. And we had alarms that would come on and said, hey, there's a problem with the air conditioner. We couldn't really resolve exactly what it was. We would get a message saying air conditioner's got a problem, but we were able to measure the internal temperature all the time with the SNMP, and it was real handy to be able to do that. And I think my experience, as limited as it is with those, is that the air conditioning people who don't work in who work in more of an industrial setting don't know anything about that at all. If you've got air conditioners that are working in a big computer room or a big central office or data center, they are going to know much more about it. So something to keep in mind if you're doing air conditioning for a new transmitter site or whatever. You might want to talk to people who do data centers so they understand a little bit more about what kind of information you can actually get out of an air conditioner.
Yes, actually, I was working recently with a gentleman in a studio air conditioning system problem, and found out that the company that they use, the two of the techs that came out just so happened to be the ones that are also called to operate to go to an AT&T data center facility. So they're familiar with the need, understanding, and it was a great experience talking with them and explaining to them the studio setup, and they understood the BTUs and all the other heat loading conditions and airflow and what's proper and not. And they actually were able to say, well, this place is built pretty well, and so you actually got more fudge factor, if you will, than most places of this size. So, yeah, there is something to be said. If you do have an air conditioning company that's maintaining your facilities, transmitter studio, whatever, it wouldn't hurt to just talk to them and find out if their experience is in data centers or data type, heavy heat load facilities, I guess would be the proper thing, mission critical. Oh, is Kirk with us, or is he still trying to get connected?
There he is.
Oh, there he is. Ah, the muted Kirk Harnack. I see finger movement, so we're going to sign a little. The sign I'm going to show you is can't hear you. My hand's going across my neck. Nothing there. Oh, and his signal to me was index finger in the air, vertical. Okay, got it. One moment. Excellent. See, look, it's a visual medium, but sometimes it's audible as well. Or it's the other way around, I should say. It's audible medium, and now we have visual. Who would have thought? So how are things on the West Coast? Or was it the left coast or whatever people joke about, Doug?
It's the left coast is the best coast, of course. Things are great. The weather has been absolutely fantastic. I mean, I enjoyed 6 years and working in New York and living across the river in New Jersey. I don't miss the weather situation too much, really. I was just talking about that yesterday morning, and the humidity was the thing that really can't really get away from. It's not the temperature so much, but the humidity. And we don't have that problem in California, and it's never humid and it's always real dry. But the weather's been great, and the working in Manhattan was a great experience. It's such a grind to do it every day because, of course, I took the train and I never had a car there. Obviously, there's a lot of great things about it. New York is a great experience, and Empire State Building is a cool place. I really like 4 Times Square. It's, as far as the backup transmitter site goes, I mean, you can't ask for more than that place had. And I'm really glad to see WBGO with a great looking transmitter site moved up there. By the way, that's David Antoine, and wonderful job, and I'm sure you're keeping it in sweet and nice condition. And Empire has got its issues, of course. It's an old building, and it's something you don't really want to miss if you're in New York, though. Anyway.
Yeah. I will say I will agree with you on the Empire. I've worked in that building for many years as well, and worked out on the parapets, worked inside the combiner rooms, the E-levels, and all those wonderful places that many of us know. And yes, 4 Times Square is a great place, and it does work very well. And great support staff from the building, and the facility build-out was excellent. So yeah, it's just upkeep has been very straightforward. So I'm curious. I've worked on the West Coast a couple of times, but not anything long-term. How different are broadcasters, say, from your experience here in the New York City, New Jersey area to where you are now in L.A.? How different is the thought processes?
I don't really think it's any different. It's a myth that people back east are mean or anything like that. I mean, it's just simply not true. I mean, if you took anybody in the country from anywhere in the country and you dropped them into the kind of situation you could find yourself in New York, they could turn mean in an instant. I found that people in New York are very patient for the most part and can get along, constantly running into each other and bumping elbows and so forth, and having to get on the train and push your way in, and after a long week and so forth. I mean, so to answer your question, no, I don't think there's any real difference. I mean, we'd have to take the same approach in Los Angeles as we did in New York, where we have a very high stakes game going on. And we spent a huge amount of time learning how to back things up, making sure things are ready to go, and make sure all the backups are ready to go. I mean, they're just as important as the mains. And in fact, to the extent that we can, we always have tertiary systems put together as well. Like most of the transmitter sites, they actually have three. Let's see, let me think about that for a minute. 2 of our AMs have 2 transmitters, one of them has 3, and all the FMs have 3 transmitters and 3 antennas and so forth scattered about. So we don't want to be off the air no matter what, of course, and anybody's going to say that no matter where they're at in the country, but it takes a lot of effort, and the company has to be willing to back you up, of course. When you say, hey, we're going to do whatever it takes to stay on the air no matter what, then that's great.
Yeah, you're absolutely right.
Yeah, and the company has to be willing to do that, and of course they are. So they understand the importance more than we do.
Yeah, no, great. No, that's a great answer. I was hoping for that because I felt the same way. You're right. You could be dropped into situations here in New York and you can change your attitude real quick. But then again, I've worked in newsrooms all my life, so I can tell you that I've been dropped in many a newsroom where you basically better know your stuff or you get pushed out real fast. So it's good to hear. It's no different anywhere else you go. Now, with the remote controls, and you've done a lot of work, and I can say I've seen your handiwork at 4 Times Square. Very nice work you did with WKCR. And with what goes on these days, with everything being IP based, or interconnectivity through data, and we're back in the days we were familiar with the old DC copper lines we used to use for the dial-ups and everything else, or the FSK modems on STLs or on data lines. How do you protect? Maybe protect is not. How do you create a fault-tolerant environment? Say you're out on the weekend, you're enjoying yourself, and you want to make sure that if one of your IP pathways goes sideways, how do you find it to keep things connected? So one, you get alerted, hey, we lost one of our IP links, but we're still connected to the site, so you're still going to get stats and everything else. What have you found has been a good approach, or one that still requires a lot of thinking before you just pull the trigger on a solution and say, yep, here's what we're going to do?
I wouldn't characterize our connectivity as being that sophisticated at this point. I mean, we share radio, our 950 legacy STLs, plus some amount of IP connectivity. In New York, we did more of that. We basically all the STLs for the iHeartMedia stations in New York are essentially audio over IP. We had 2 different networks, one based on a radio link and one based on a T3 from the phone company. Now, I think in the meantime, those are all gone. I think they've gone to a high-speed IP asynchronous connectivity in the meantime. But what we did back when I was there was we had a means of detecting if there was a problem on the radio network and would simply switch over to the AT&T network. The radio itself determined that. We just used an alarm output, which was configurable to say, hey, I'm switching over to the AT&T circuit, and send an email out. And then I would simply consider later on. Actually, I had to go to the site to check out what was going on to reset it. And then the tertiary means of STL stuff in New York was all the legacy radio stuff. So if you were going to have 2 IP networks going up to your transmitter site, you could do it in multiple different ways. I mean, you could do load balancing between 2 layer 2 circuits. You could do IP routing. If you were going to have 2 separate networks, or say from 2 different providers, would be one way to do it. The thing about IP connectivity, as you know, is the whole idea is to be self-healing. I mean, that's like one of the most basic ideas with IP connectivity. So it's so easy. Well, I shouldn't say it's so easy to do, but it is easy to do based on all the various vendors and so forth that make equipment and make circuits that you can use to connect point A to point B. Now it's that's kind of a long rambling answer, but hopefully it made sense.
No, I totally agree. No, I totally agree. IP is all about self-healing, and whatever approach you take, you just consider the need for what you want to do and how you want to, what the end results are. So no, you're absolutely right. It makes total sense, and it's nice to know that you can do more now than you could say 20 years ago when you were very limited what you had access to. But that brings us to another point, and Kirk is going to come in now and talk to us about another sponsor we have.
Got my audio now? You hear me?
Yes. Just in
good,
time for
good.
the
All right.
sponsorship.
All right, good. Hey, you're watching This Week in Radio Tech, episode number 307. I'm delighted to have Chris Tobin along, asking questions when I can't be there. And Doug Irwin is our guest. Doug is the Director of Engineering at iHeartMedia in Los Angeles, and he's also the technical editor for Radio Magazine. And when we come back after this quick break, I want to ask Doug about, shifts or changes he has seen over the years in publishing. What kind of technical articles? I mean, hey, 20 plus years ago, I wrote an article for the old Broadcast Engineering magazine about airflow in transmitter sites. And, we were taking a cheap approach. And I just want to kind of see where have things come from there? What are their hot topics now? So, Doug, if you could get ready to answer that here, I'd appreciate it. All right, our show is brought to you in part by the folks at Zipstream. Zipstream, a range of hardware and software products from the Telos Alliance to get you streaming. Not only, hey, you may be streaming now, but does it sound good? Does it sound as good as it can? Is it easy to find? Is it is the quality there? When you're doing ad insertions or when you're doing metadata, does it look good? Well, Zipstream, either hardware or software, can help you out. Let me talk to you about the Zipstream X2 and its big brother, the Zipstream 9X2. This is software that runs on a PC, and it runs on any flavor of Windows, Windows XP on up to Windows 10. And it runs as a service, first of all. So it doesn't run as an app. It runs as a service. And that means it's going to be more reliable in the Windows environment. It's going to be as reliable as print drivers and all the other stuff that runs as a service in Windows. And you access it on your Windows machine by using your browser. You just browse to localhost, and it's running its own web server right in there, which also means you can access your streaming setup remotely if you need to, by just getting into the computer remotely, because it's got its own web server built in there. So what about Zipstream 9X2? Well, 9X2 implies you're getting the Omnia 9 audio processing in there. Now, I got to tell you, I used to think that Omnia 9 processing was a bit overkill for a stream. But I'll tell you what, we have happened upon some presets for the Omnia 9 processing at low bit rates that sound amazing. And I've been able to put these presets on some of my radio stations. You'll also find examples of Omnia 9 processing on other radio stations as well. Here's how you do it. Go to telosalliance.com, telosalliance.com, and then click on the streaming. Let me see if I can tell you a better way to get there. Go to processing and encoding for streaming audio. That's under the Telos header. It's also under the Omnia header. So processing and encoding for streaming streaming audio. Go to the Zipstream 9X2, and then if you slide down on the right-hand side, there's some examples. It says, hear it for yourself, and go to these people are already streaming like they mean it, okay? So look for that. These people are already streaming like they mean it. It's a list of stations and their streaming URLs that you can go to and hear different streams at different bit rates, different audio formats, different radio formats, and these are all using the Omnia 9 processing. Now, a few of my stations are on there, and I'm just delighted. We got an expert to help us out, a guy out of the Netherlands who just does streaming and stream processing for a living. And someday we're going to have him on the show, actually. We're going to interview him about the things that he thinks are important for processing for streaming. But if you listen to these different streams, and then there's some higher bitrate streams as well. Summer XI, Your Choice, Your Music. Summer XL. It's a dance format from the Netherlands. They're streaming at 192 kilobits per second MP3. Galaxy House Music, or Galaxy World House Music. It's dance from France. Also, 104.9 The River, WCVO, is streaming. These are all examples of people streaming using the Omnia 9 processing in Zipstream 9X2. Am I excited about this? Yeah, because since I started using the Omnia 9 processing in my streams at my radio stations, I got to tell you, clarity even at low volume, real clarity, sounds great. Bass that is strong and just can vibrate the speakers if you turn it up high enough, and a high end that's frankly pretty amazing for these low bit rates. We're talking HEAAC V2 at like 48 kilobits per second. And yeah, I know, look, it's not linear audio, but man, is it good. It's really good. I have listened to this in the car, tooling down the highway. and streaming audio for hours at a time from my radio stations and others as well with this Omnia 9 processing. And it just sounds so appropriate. It's loud, it's bright, you can hear everything, and especially if you turn it down to low volume, you can still hear the words, hear what people are saying. It's just exactly the right kind of processing. I want you to experience it for yourself. You can go to the website, telosalliance.com, and you got to search around, find the process, find the streaming and encoding, and then people who are already streaming like they mean it, and hear for yourself. I'll put the link in the show notes. How about that? That way you can get right to it and listen to examples of other people streaming. And hey, this is your transmitter for the internet, right? You want to take this seriously now that there are serious numbers of people listening or available to listen. And the question is, are they listening to you or are they listening to some other service? Well, how about you get them to listen to you? And hey, even at my little stations now, if our stream goes down, like if our internet dies at the radio station, we get phone calls. So, you may be getting phone calls too. So people are starting to depend on your stream, and it needs to be there and sounding really good. Zipstream, stream like you mean it from the Telos Alliance. Thanks a lot, Telos, for sponsoring This Week in Radio Tech. All right, it's episode 307 with me, Kirk Harnack. I'm at the Star 94.1 studios from Entercom here in Atlanta, Georgia. Chris Tobin is in his lair there in New Jersey. And Doug Irwin joins us from the iHeartMedia radio stations in Los Angeles. Gentlemen, welcome back in. Glad you're here. And I wanted to ask Doug about changes that he's seen in the emphasis or the focus in technical articles over the years in Radio Magazine. And what does that tell us about the state of the industry? Doug, can you characterize that for us?
Well, it's really an easy one, and the change is simply this: as computer technology has changed and become more and more and more of an important part at a radio station, it's become more and more of an important part in Radio Magazine. We have a lot of articles that have to do with audio over IP and studios that are built based on audio over IP and network security. We've been talking about that a lot lately. So, I mean, that's the obvious change, and that's an important one. As technology changes, of course, we follow along. We try to keep track as best we can, and we're trying to keep ahead of the game and study what's coming and what's going on, and try to understand what the state of the art is, so that we can write articles about it and find people who are experts on that. So that's it in a nutshell. And as it goes more and more that way, you're going to see more and more articles about that. I mean, people are very interested in reading articles about transmitters and stuff, and it's true. We still do them, obviously. But that's not all there is to radio engineering technology anymore. It's not just a transmitter and an antenna. It's way more than that.
Along with new technologies and the benefits, I've been excited about audio over IP technology for years now, especially since my employer does a lot of that. But along with benefits of a new technology come some dangers, some things you can step in if you're not careful. We've seen in the news lately about another radio station whose IP audio codec apparently was on the air. It was accessible to the public. It was publicly exposed on the internet, and some people took it over and put some naughty stuff on their radio station. So IP security or IT security is a hot topic. Did you find, Doug, interest in this topic as well, and the need for engineers to get educated about this?
Well, the need is certainly there. I hope there's a lot of interest. I hope the interest doesn't just get generated after the fact, and that people understand ahead of time that there's a danger they need to be aware of. I'm lucky because I don't deal with that part at all. I mean, as I mentioned, I describe what I do here, but I know in the majority of radio stations around the country, you've got one guy who's doing everything, and he could be an expert in transmitters and suddenly be forced to be learning about network security. So, just to plug Radio Magazine again, we've done a couple of articles in a row. We've had a series of articles from Chris Cottingham about that very thing. Chris is very good at IT. He happens to be chief engineer of KFMK in Austin, but he used to train. He used to do training courses and so forth for CCNA and A+ and whatnot. He's very good at it. I recommend that kind of thing. I recommend it to read him. But we're going to do more of that, of course, as time goes on. It's going to continue to be an important topic.
Chris Tobin, I'm sure you'd agree that there's a trade-off between convenience and security in the IT world. And as engineers, sometimes we're just forced to, hey, make something work and get it to work. And getting it to work, the first time and easily, sometimes we forget about security. And a perfect example, and Chris, you can probably think of your own and have your own advice. I'd like to hear it. But hey, years and years ago, in fact, it was probably about 20 years, almost 20 years ago, I was building a radio station in American Samoa, and back then we didn't have NAT routers. They just gave us 5 public internet addresses and told us to plug in and hook a hub to it. And we were running whatever Windows was out then, and Windows 95 probably, which had stuff just exposed. So our C drive was exposed to the public internet, and guess what? After a year of operation, somebody came along and wiped our C drive out right there because it was just there. I didn't know any better, but boy, I sure started educating myself quickly. Chris, what do you have to say about that? That's an extreme example, but hey, to get taken over with your audio codec, man, what do engineers need to be doing about this?
Doug's point was well taken. Is that you need to understand and learn it. The articles that were in Radio Magazine, I read them. They were very good. They explained very nicely why and how you do things. And nowadays, you have to be serious about it. I've worked with several folks recently who gave me information on how to access some of their systems, and I discovered that one, their systems were exposed in the sense that they're looking at the public side of their network. The passwords they were using were not as strong as they thought they could be, but the fact that the equipment was already looking at it was exposed was something I said, guys, you really should consider putting this behind a router of some type, or do a little more than just this. So I think broadcast engineers need to learn more and understand why. And yes, the more security, the inconvenience it creates. But the point is, it's a risk assessment. If you're going to take a chance and put, say in this case, an audio IP codec on an exposed port because it's convenient for the person in the field to connect to it, then be prepared for what could possibly happen, as we know those radio stations that suffered that. So these are things to consider. So I would say education, learn more about it, and security passwords and stuff you could create don't have to be totally, random to the point where you need a piece of paper to remember them. But there are ways to create levels of security that can keep you safe, still access what you need to do, and do it right. So that's the trick. The trick now is to learn it, understand it. That's the way I would go with it.
If any of your passwords are password or monkey or 1 2 3 4 5 6, you probably better check your security policies.
No. Password #11#5. That's secure.
Ah, okay.
I was given that once.
My password is 8 asterisks. not even the IT people know what it is. Yeah, that's right. Hey, so Doug, we can look for more from Radio Magazine, from Radio Mag via from Chris Cottingham, right? On IT security.
Yes, indeed. The current article is in the, is that in their June or May edition? It all starts to run together after a while. The current edition's got Chris's latest article about that in it, but there'll be more in future. Actually, about a year ago, Scott Bridgewater had another series that was very good as well. Chris has been doing it the last 6 or 8 months, though. So, yet more to come.
All right. I would like to mention also that at spe.org, you'll find webinars that have been done that you can take as well. So there's been some very good stuff there. Hey, we got a quick message from our last sponsor, Lavo, and when we come back, Doug doesn't know it yet, but he's going to have a tip for us. It's a tip of the week: a website, a tool, a process, a procedure, something that we can take home and say, "Yeah, I learned this from Doug Irwin." Doug, you got 90 seconds to think about it. Maybe Chris Tobin, and maybe you got something as well. Hey, our show is brought to you in part by the folks at Lavo, L-A-W-O, Lavo. Everywhere you go, you find what? Touchscreens. Laptops are coming with them now. Supermarket checkouts have touchscreens. So do the radios in new cars. Yeah, complete with fingerprints. Even airplane cockpits are getting touchscreens now because they make your life simple and natural. If the UI is well designed, that's important. Well, the intuitive controls on a touchscreen can make your tasks faster and fewer errors in there as well. Isn't it time you brought the power of touchscreens to your radio studio? Well, you can with the crystal clear virtual radio console from Lavo. Crystal Clear gives talent an instantly understandable multi-touch interface. Faders, meters, clocks, timers, talkback, and even more live in harmony on a single screen, so your shows run smoother and sound better. Crystal Clear features Lavo's exclusive Auto Mix. That's the hands-free smart mixing algorithm designed for fast-paced multi-mic talk shows. And there's Auto Gain. Just push a button and the preamp calibrates automatically while your guest speaks in the microphone. So with that kind of advanced automation, talent can even, dock the mixing controls to the side and use the screen to do other things like working with delivery systems, audio editors, or phones. Crystal Clear's power plant, that is that's the crystal part of it, measures just 1 RU. That's pretty amazing when you consider the amount of DSP on board. Compression, EQ, voice processing, and precision delay can be applied to all of your mic, line, and digital sources. Optional upgrades include redundant power, MADI, and Ravenna, and AES 67. And all of this power costs no more than what you'd spend for an ordinary board. Thinking about a new console? Well, don't decide before you check out Crystal Clear from Lavo. Go to www.lavo.com, that's LAWO, and read about it. Or call Bill Bennett at Lavo USA. Bill's number, here you go, is 888-810-4468. That's 888-810-4468 to find out more. Bill Bennett in the USA. The future is clear. Lavo, crystal clear. Thanks to Lavo for sponsoring This Week in Radio Tech. And before we get to our tip, I got one more thing to show you. These studios where I'm at, they're just about to install a new phone system. Here, let me show you the old one. Now, a lot of you recognize this. Here is a Telos desktop director. It weighs a ton, but it's been an industry standard for years and years. Well, those are about to go out the door because coming in, our very own Joe Mock at Telos is about to configure these phones. This is a Telos VSET 12. This one's labeled FM1, so I'm assuming this goes into FM Studio 1. And so anyway, they're gonna be all VoIP here at the Intercom Studios in Atlanta pretty soon. I just had to show that to you. Next time I come back, well, they'll all be installed, and we can check that out. All right, Doug Irwin, would you have a tip that you might pass along to our listeners and viewers?
Yeah, you put me on the spot there so much. I've been thinking about that last 90 seconds. I'm just thinking about an April Fool's Day joke. Just keep in mind that the dynamic microphones can also be used as speakers, and you can send audio back to them. Can make a really very funny April Fool's Day joke. That's all I can think of. No.
Tell me how would you now? How would you do? And practically, would you put the mic feed in a relay so you switch it and then feed it some audio?
Basically, that's about all you can really do. Yeah.
Wow.
Anyway, just think about it for next April. You got a long time.
Oh my gosh, I'm coming up with all kinds of evil ideas now. I love it. It's cool. Chris Tobin, are you full of evil ideas yourself?
Not at all. Not that I would say publicly. The guys at Press 195 know better. Hey, my tip something to remind everyone. I've probably done this a couple of times before, but I'll bring the screenshot up here. This is a screenshot of speed test. We're all familiar with that. This is an iPhone, and it shows a ping time of 5 milliseconds, bandwidth up and down, about 22 megabits symmetrical. The one thing I wanted to point out is I was doing some work this week with an audio IP codec at a small studio, and just below the speeds, you see what looks like little finger or grassy, graphical representation of the data rate.
Yeah.
And
sure.
Interestingly enough, this particular screenshot, the one for the download, there's a gap between those little haystacks. If you can see,
wow,
I'm not sure.
I see that.
You can see it, right?
Yeah.
So I did the test. I'm like, wow, that's interesting. And then we're doing the measuring some stuff, and we're listening to the audio download, the audio codec connection. And sure enough, we're hearing dropouts, and we're looking at the specs, the stats that is, and the jitter, the buffer, everything was working really hard to try and make up the differences, and we're trying to figure out what was going on. Right. Later, we discovered that it was a rogue Ethernet card that went berserk on a computer on the network. It was just broadcasting packets like crazy in a cyclical way. But it was interesting that I sort of had caught it going, wait a minute, well, this is weird. Why are we seeing this? And then backed it up with the actual codec saying, doing the same thing with its stats, its diagnostic capabilities. So, speed test is handy. Try and look at it a little more than just a quick little dial that says, hey, I got this speed, that speed down and up, and that's it. Try and decipher a little more what's going on. And, if you have a ping time that says like 300 milliseconds, even though you may have 30 megabits up and down, you might want to wonder why it's, the ping time is high. I've had a few that it was like 300 milliseconds, but it's 55 meg up and down. Like, but I'm still kind of concerned about that transit time. There's something's up. And 9 times out of 10, there's usually something wrong. And other times you look out and it just goes away. And do Chris, 2 or 3 ping tests. I mean, a speed test, not just one.
Yeah. If I could glom onto your terrific tip there about analyzing that little graph that's given. Let me show you a graph that I just did this ping test or this speed test. Now, the download is really consistent. And I realize that's not a lot of graph points, but you can determine something valuable just from that. The download is great, and it's consistent. But look at the upload. First of all, it's horrible to begin with, about a maximum of 600 kilobits per second. But look at the variation in it. It started out. I mean, it started out a little bit okay, and then it got really, really bad. And would you want to try to do a live remote broadcast with that kind of upload speed? No, you could not rely on that at all. And so you can actually tell a reasonable amount from that free little app, speedtest.net. Good advice.
Well, especially if you're doing Wi-Fi. So yeah, you definitely got to be careful.
Yeah, this was on the 4G LTE network. And hey, I'm right next to I-75 out here. I'm sure there's hundreds and hundreds of cars on whatever cell site that I'm on. I've gone to places where the upload was a solid 12, even 20 megabits, just solid. And you could do video, high def video from there all day long. So it really varies per cell site.
It's the allocation of those resource blocks. It all depends on the LTE site. But then again, there's that new service. So is that they're doing the video over LTE stuff, the EBEMS, EMBS or something like that. I've been reading up on that too. That's been interesting. Phone company's going to get into doing video.
Hey, we got to go. Doug Irwin has been our guest. Doug, thank you so much for joining us. It's good to hear from you. You're in your happy element there, doing lots of outside work at iHeart. And I think you're doing a great job as a technical editor there at Radio Magazine. I love the articles. Please keep up the good work.
Thank you very much, and thanks for having me on. I really appreciate it. It's been fun.
Thanks for joining us, and love to have you back on again sometime. And I want to hear this stuff that engineers need to learn to better automate their sites, to keep them apprised of what's going on and what's going wrong, and automated testing. I'd love to hear about that. And Chris Tobin, thank you for joining. Oh, I'm sorry, Doug. What?
Just stay tuned. Keep reading the magazine because there's going to be more of that coming up.
Every month, cover to cover. Do it.
Great.
And the website's good too. It's Radio Mag Online, right?
Yes, it is. Thanks.
RadioMagOnline.com. And in fact, I think you can sign up for is it daily or weekly email from you guys from the magazine?
There's 4 different newsletters that come out. One comes out every 2 weeks, and the other ones come out about once a month. Once a week, I believe.
If you subscribe to all of them, then you might get some pretty often. So.
Yeah.
All right. Chris Tobin, thank you for joining us as well. Appreciate you taking your time out, and thanks for filling in during the glitch here. I appreciate it.
No problem. You're quite welcome. And Doug, kudos to you. Your guidance at the magazine is definitely enjoyable, and I've found many good things. So I have to echo Kirk's sentiments. So good job. Good choice.
All right, Chris. Thank you. Appreciate it.
Hey, program note: next week on Thursday, our guest is from Norway. His name is Ketil Morsdal. Ketil Morsdal. He's going to compare different audio over IP systems for us, like Dante and Livewire and AES67 and WheatNet. He's going to compare these and talk about their strengths and weaknesses. So I'll be very curious to hear about those, and I hope you'll join us too for Ketil Morsdal on This Week in Radio Tech. All right, thanks for being with us, everybody. We appreciate it. Thanks to our sponsors. Appreciate Suncast once again doing fantastic work there at the GFQ studios in Queens, New York. And we're gonna go. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.